We'll get started. So I hope you all had a wonderful long weekend. I certainly did. Very, very happy with the test results. Well done, everybody. And so we'll just get straight into the next unit, which is applications of calculus. Now we'll talk about our plan today. We're going to go through tangents. Now, in the Hazy textbook, they just cover tangents, but tangents and normals are part of the course. So we'll provide some supplementary questions on normals as well. But tangents and normals is a skill we have done before, but it's going to have increased complexity given that we know more differentiation now. We'll have a look at our tests. I'll hand them out and there'll be an opportunity for some reflection on that. Got some solutions floating around too. We're going to look at how we can use our calculator to support us. We've got our calculator from now on for the rest of the year, okay, for all the tests and the exam. So this is your best friend, and we've got to learn how to use it to help us. In the next test coming up, definitely it's a good tool. And then lastly, we've got a new booklet coming out on conjecture questions. So this is a sort of a new part of mathematics for you. They're lots of fun. And I think just like how we have some really challenging first principles problems, these really illustrate the complexity of maths. That's sort of as complex as it can get. And we're going to go through a couple together, and hopefully you feel really confident, yep, I'm in the right place, I know how to do that. So let's get straight into these tangent questions then. Now we're going to explore today, we've got 3 processes we can do to find the equation of a tangent and the equation of a normal. Now very quickly, if I have a curve, a tangent then is just a line that is parallel to the curve and touches it at that point. Okay, so we're finding the equation of a line. It touches the curve at that point and it has the same slope at that point. Okay, a normal is a line that is perpendicular, so that means it would meet the tangent at 90 degrees. So a line is going to have the same slope as the curve. A perpendicular line will have negative reciprocal slope. All right, so concepts that we've explored in year 11, but we will really reiterate today. So I've said we're going to do 3 processes for tangents. All right, the first process is just like an intuitive process based on how we find the equation of a line. The second process will be in general form. And I know if you're in my class last year, you definitely did general form for the equation of a line. And then lastly, the last process will be the formula. Okay? Now, you need to be competent with all 3, okay? Because you do need to know how to find lines. You do need to know how to find lines in general form because conjecture problems pop up in general form. And the formula, it's just sort of useful extra to know because it can be the most efficient way of doing them. And once you're competent with all 3 processes, then you can just pick your favourite one and just do that over and over and over again. Let's get straight into the first question. We have the function of the square root of x, and we are asked to find the y-intercept, the tangent in y-intercept form at x equals 4. So if you have the square root of x function, this is what it looks like, by the way, and we're finding the tangent here at x equals 4. So I'm finding the equation of this line. So for a tangent, we always need 2 things. We need what's called the point of contact, the POC. And that's where, just like you think back to ARUC, we got lots of cool little acronyms here, POC, point of contact. And that's where the tangent touches the curve, where it has contact with the curve. Now we're told the x value is 4. And so in order to find the y value, we're just going to put the x value into the original function. The square root of 4 is 2. Now, when we're given the square root of x function, we only consider the positive circumstance. All right, so that's why I'm not putting plus or minus 2. We only consider the positive circumstance. All right, so we need the point of contact, and the other thing we need for a line is the slope. And this is where the calculus comes in. If this is the function, that tells you the y value. The derivative function is going to tell me the slope. So my function is x to the half, which means my derivative function is half x to the minus half. All right, and we can express that as 1 on top of 2 root x. Okay, we've got the half and then x to the minus half takes it to the bottom, and the half makes it a square root. And so that's the slope function, right? That's f dash of x. And we want to know the slope when x is 4. We want to know the slope at that point. So we're finding f dash of 4. So that's 1 on 2 root 4. That's 1 on 2 times 2. That's the slope of 1 on 4. Okay. So for a tangent, you need two things. We need the point of contact and we need the slope. So you get a mark for finding your point of contact, you get a mark for finding your slope, and now we're going to combine them together to find the equation of a line. And so from here, this is where you sort of pick your favourite process. And I've said we're going to just start with an intuitive process. We're finding the equation of a line with these properties. So the equation of a line has this form, right? That's y-intercept form, where m is the slope. Now, our slope is a quarter, so I'm just going to drop that right where the m is. Okay, and then we need to find c. C is the y-intercept, and we've got when x is 4, y is 2. So we can write that when x is 4, y is 2, and we're going to plug both of those in. We're going to put 4 where the y is, 2 where the y is, and 4 where the x is. That's going there. And then we have plus c. And we'll evaluate this. A quarter times 4 is 1, plus c. And so our value of c has to be 1. Alright, so that means the equation of our tangent then is a quarter of x plus 1. If we sketch the function y equals root x, and we sketch the function y is a quarter x plus 1, we'll be able to see that it is tangent at that point. Okay. Alright, so break it down. What do? Find the point of contact, find the slope, alright, and then I just found the equation of the line with those properties. Very good. So let's move on to the second one then. We have find the equation of a normal in general form. Okay, so this time we're finding the equation of a normal. To the same function, we still have the function is the square root of x. Okay, so we still need those things. We need the point of contact, and this time we have the x value is 9, and the y value is going to be the square root of 9. So 3, we consider the positive circumstance. Now, we've already got the slope function, okay? We've already differentiated f of x, and this is what we got. So we have f dash of x is 1 on 2 root x. You could do it again, but it's for the same function, so we don't need to. Now, what we do is we find the slope when x is 9. All right, so when x is 9, f dash of 9 will be 1 on 2 root 9, which is 1 on 6. So that's the slope of the curve. That's the slope of the tangent. All right, that's the slope of the tangent. Now we are asked to find the normal, which means we find the negative reciprocal. Okay, so this is the slope of tangent. So therefore, in order to find the slope of the normal, we flip it, so it becomes 6 on top of 1, and we multiply it by negative 1. So it's positive, it becomes negative, and so that means it's negative 6 is the slope of the normal. Okay, so if you're finding the slope of the normal, there's one extra step involved, that is performing the negative reciprocal of the slope. Alright, so that means the slope of the line that we're finding is minus 6. I'm going to write it as minus 6 on 1, because we're about to perform it in general form. Okay, minus 6 on top of 1 is the slope of the normal. We've got the point of contact, we've got the slope, we're ready to crunch it. So, if you haven't done general form before, it's going to be absolutely fine. Have a look basically in the middle of page 22 to express in general form. Let us recall. And I've got if slope is 3 on 4 and it passes through this point, then we would write 3x take 4y. Okay? If slope is minus 3 on 4, then we would write 3x plus 4y. Now up here we have slope of minus 6 on 1. So that means we're doing the second point, which is going to be 6x plus 1 mod of y being equal to c. All right, and this is capital C, this is not the y-intercept. Okay, so I've got minus a on b, it goes to ax plus by, and then in order to determine the value of this constant, all right, plus 1, and we don't need the 1 there, but I'm just putting it there to demonstrate that number goes here, that one goes there, and if the slope is negative, then we're always going to have a positive in here. Okay? Just follow the form that's presented to you. All right, what we're going to do over here is we just have 6 times the x coordinate, and then plus 1 times the y coordinate. All right, why 6 times the x coordinate? Well, because it's 6x. Why 1 times the y coordinate? Because it's 1y. And so the equation of our normal then, 6x plus y, is going to be 9 6s are 54. 6x plus y equals 57. Okay, that's the equation of the normal in general form. All right, now there'll be opportunities to do this still over and over and over again. Okay, so what did we do? We found the point of contact, we found the slope of the normal, and then we just put it into general form by following the dot points that are presented to us. That's all it comes down to. 6x plus y is c, we sub in the point, and there it is. That's general form. And we could rearrange this to y-intercept form by moving the x over to the other side, right? You see, if I move the x over, now we would have y-intercept form. Okay, y equals mx plus c. Very good. Okay, let's have a go then at 2. Consider y equals sine of x. Find the equation of a normal at x equals pi on 3. So let's have a look. We've done an intuitive process, we've done general form. Let's do the formula. So I'm going to write the equation of the formula up here. And we have the normal at x is a is y equals minus 1 on f dash of a times x take a plus f of a. All right, so we have a formula. Now, I'm asked to find the equation of the normal in this question at x is pi on 3. Okay? So at x is pi on 3, yeah. So what that means is y equals 1 on f dash of pi on 3 multiplied by x take pi on 3. We're subbing pi on 3 for the a value, okay? That x stays as is, and then over here plus f of pi on 3. Now it can be helpful just to write it out like this, all right? There needs to be a negative there because it's normal. And I'm getting that formula from basically just above where we talked about general form. I've got the equation of the tangent and the equation of the normal both written there. So that's where I pulled that formula from. And we're finding it at pi on 3, so I've got f dash of pi on 3, x take pi on 3, plus f of pi on 3. Now, our function is sine of x. All right, and our derivative function then, the derivative of sine x is cos of x. Now, we want to know what's going on at pi on 3. We want f of pi on 3 and f dash of pi on 3. So if I put pi on 3 into this equation, I'll have sine of pi on 3. All right. And if I put pi on 3 into the derivative, so f dash of pi on 3, I will have cos of pi on 3. And we'll look at our unit circle for pi on 3. The sine value is root 3 on 2. The cos value is half. All right, so we've got f dash of pi on 3. That's half. That's going to go there. We've got f of pi on 3. That's root 3 on 2. That's going to go there. So let's just state what we have then. We have minus 1 on f dash of pi on 3, minus 1 on half times x take pi on 3. Alright, that part's just staying as plus f of pi on 3, well that's root 3 on 2. So we're just bringing all those parts together. Now minus 1 divided by half, that will simplify to minus 2. And that you can put in your calculator now because you've got it, although I would assume you'd break that up into 1 on 1 and do AD on BC. That gives us the minus 2 times x take pi on 3 plus root 3 on 2. And if we expand this, minus 2x plus 2 pi on 3 plus root 3 on 2. Alright, so what have we got here? We've got the equation of a line. This is the value of m. M is the slope, always the coefficient of x, the number in front of x. Okay, so the slope of our normal is minus 2. And then this whole thing left over then is the y-intercept in exact form. Okay, this is going to be an irrational number. We've got pi, which is irrational, and we've got root 3, which is irrational, but we've expressed it there exactly. Very good. Okay, so we've done 3 processes, right? We've used the intuitive process, just finding the equation of a line. We've used general form, and now we've had a look at the formula. So, on to the last one. Find the equation of the tangent to 2e to the x at x equals ln b. So, our function is 2e to the x. So, point of contact. So when x is ln b, all right, that's the x value. And the y value then will be 2e to the ln b. And e to the ln b will just simplify to b. And that 2 is just hanging out. So the y value is 2b. Okay, then for the slope, we would need the slope function. So if I differentiate this function, the derivative of e to the x is just e to the x. The 2 hangs out. So the derivative function is the same as the original function, 2e to the x. And we want to know the slope at that point. So we want to know the slope when x is ln of b. And remember, we're dealing with some letters here, but it doesn't matter, all right? We just treat it the same as we would a number. 2e to the ln b simplifies to, well, that simplifies to b, so 2b. All right, so we've got the point of contact, we've got the slope. So let's just do the intuitive process. Y equals mx plus c. That's the equation of a line. Our slope in this circumstance is 2b. Now, if you want to put brackets around it so you can see clearly. This whole component is the slope, and then it passes through this point. When x is ln b, y is 2b. So we'll put 2b where the y is, and we'll put ln b where the x is. All right, ln b where the x is, put 2b where the y is, and this plus c, that's exactly what we're trying to find. Okay, so this just means 2b times ln b. I'm going to subtract that component from both sides. That 2b stays there. And then I'm going to move this component over. So I have to take 2b ln b, which means we're just left with c on the right-hand side. Okay, so that's the value of c, which means the equation of the tangent is mx plus c. It's 2bx plus, and what's the value of c? Well, this whole thing that we solved for here, which is 2b take 2b ln b. All right, slope, y-intercept. Okay, then in part B, we're just told a little bit more information. Given the tangent at x equals ln b has a slope of 4, find the value of b. All right, so the slope at this point is 4. Here's the slope, 2b equals 4. So the value of b is 2. And then we could go through and evaluate this further if we wanted to, but it just tells us find the value of b. Okay, so we started with a few okay ones, and then we got to a little bit more complex there, where we're performing the same processes, except we're using letters instead of numbers. So, until recess, all right, I want to be very deliberate about what you need to do. Now, this exercise is a fat exercise. This is exercise 3A. And I wouldn't expect that you would get through all of the questions today or tonight and so forth, but I just want us to have a solid attempt. So let's just start with question 1. You can start with question 1. I'm going to make a list of questions I would like you to start with up here on the board. So that's where we dedicate our efforts for the start of the lesson today.